Okay, is this recording? Yes. So how to post-process the data. For example, if you want the P, well, this is not ideal. If you want the PQ plot of a point in front of the pile, so this is a 2D slice, which is used to obtain PY curves. This is just the mesh evolution in time. So first thing first is I have the data. Here you can see that the initial patterning has been, well, mostly left behind in the back of the pile and thinned down outside, but also that the modified zone is now much bigger with a few cracks propagating through the material. And I have the stress invariants, PQ, etc. So let's say PQ here. Let's say I want a plot of the value either at a fixed position or a fixed distance from the pile, and you don't have this data extracted from, how will you say, from the simulation itself during the simulation using Python, which we'll look at later on or at another time. What you can do is extract, file, export, plot information, ASCII file, so just txt, and gonna call it pedone ASCII mesh. And it's they already exist, overwrite yes. And so I'm gonna start again later. Okay, so while we wait for the other file to pass, we can have a look at the data structure of the result files. So we exported in the mesh the result in ASCII form. This is just one step or a small amount of steps from another simulation. So in ASCII format, so you can see you have the mesh for a given time step from the very beginning, which is divided in, first of all the nodes are provided with the ID of the node and the XYZ position here. And afterwards, after all the nodes, you have the same thing with the elements. This one is for the linear elements, so it's ID and the node number, so it's 2, 1. It's pretty much useless. And then you have the same thing, but instead of the okay, so this can just be skipped. What we care about for the 2D mesh, which is the same for the 3D, just one extra node ID here, is you have this part of the text which is called Kratos mesh triangle, 3 nodes for each triangle. So you have the ID and ID1, ID2, ID3, and I'm not sure what the 2 stands for, but yeah. And this just repeats, and for each step you have for each step you have a list of linear elements and a list of node coordinates and a list of meshes or elements per se. And this is the mesh. Then we have the result file, which is like this, which is divided between Gauss point data and node data. And basically for every step result, it gives you the name of the variable, and which has different dimensions depending on the variable. Element type, triangular element, 0 is the time, where Gaussian point. For example, this is since it's a symmetric matrix, you only have 6 components: S, X, X, Y, Z, and the shear stresses. So you have an element number and the 6 values for a given step. And going downward, for example, here you have nodal values. So you can see our own node. It's a vector. Since we are doing 2 dimensions, you have the node x, y, well, 3 dimension, x, y, and z, which will always be 0 in our case, and the modulus, and this repeats. And pretty much all the format is always the same, where depending on whether it's a scalar or a vector variable or a matrix variable, you have the ID of the mesh, of the node, or of the element, and the associated value. And this is the script I'm using to extract the data. It's pretty much the same for 3D and 2D. I should have another one for 3D, I think, but it's pretty much the same. The way it works is that it gets all the files in the folder with a given name, for example, this one, all, well, not .ped, all the files called pedone, music will drain path the ASCII. It opens the mesh file, extract for each step all the nodes, and then map nodes here, and then all the elements, and then opens the results file and splits depending on the variable name. So if you just run this, you can see here it's extracting the mesh. It can take some time depending on the size of the model. So if you have more than 100 or something steps, I would suggest exporting the data every, I don't know, 10 steps or something like that, so that it doesn't take too long for you to export it. So I'm gonna pause it. Okay, so the code has finished exporting all the data, which you can see here in the text, and we have created 2 different files for each well, folder, which is the mesh data and the results, which let me scale a bit. Yes. Okay, this should be more visible now, which you can see it's a matrix or a structure of 1 by the number of steps. So in this case, my mesh is, for each step, you have the nodes and the elements, so x, ID and x, y, z, and ID and x, or ID1, ID2, ID3. I don't know what this is. This is just rubbish. Don't consider it none. And same for the nodes, if I can open it. So this is whatever. It's just position along Z, which is just 0 since the 2D model. And this is ID and position. And then you have the equivalent, which is result matrix, which you have for each step. You have both nodal values, for example, your contact force and or displacement, and you have element values, for example, the stress tensor here, which is, as we showed earlier, since it's a symmetric matrix, you have 6 SXX and YY and ZZ, which is whatever, and SXY, YZ, and XZ. So the matrix, and this is the element it's associated with. And in the next episode, we will see how to post-process this. Like and subscribe and whatever.